The next topic to discuss is the triangle inequality, which I think is a pretty important and also a pretty powerful theorem that we have in geometry. And to explain it, I built a triangle and I've measured the three sides. Okay, now what I want you to notice is that the smaller two sides added together is bigger than the longest side. So however I move this, that those two smaller sides will always add to be bigger than the longest side. Now, which side is the longest may change, but however you move it, the shorter two sides added together will be bigger than the longest side. And that's what the triangle inequality says, that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Now, before we use that theorem, I want to briefly explain why that happens. Okay, now this diagram may be a little confusing, and if so, then don't worry about it. But what I've built here is that this is the longest side of the triangle, okay? And the other two sides purposely add up to be less than that longest side. Now, however I move these two sides, they will never touch, and they'll never form a triangle. But if I make these sides longer so they overlap, meaning that the length of the two sides are bigger than the third side, then you can see in red here that a triangle is formed, okay, because those two sides now can touch and create a triangle, okay? So if the length of the two shorter sides added together are bigger than the longest side, then a triangle can be formed from those three sides. And that's why the triangle inequality works. Now let's use this inequality. Now the question is, can a triangle have sides with the given lengths? 3, 7, and 8. Now the triangle inequality says any two lengths added together is larger than the third one. But the one that's most important to us are the shortest two. So I'm only going to look at those. So the shortest two, 3 and 7, 3 plus 7, is that greater than 8 is the question. All right, well 3 plus 7 is 10, and 10 is bigger than 8, and so the answer is yes, a triangle can be formed using these two lengths. The next question, 5, 10, and 15, the shortest two are 5 and 10. 5 plus 10, is that bigger than 15? Well, 5 plus 10 is 15, which is not bigger than 15. It's equal to it. So the answer would be no. Okay? And our last problem, in the Solve It, you explored the process of dimensions of a triangular sandbox. Two of the sides are 5 feet and 8 feet long. What is the range of possible lengths for the third side? Okay, now this can get a little complicated. Now that third side, you can think of it as either being really short or really long. Okay, I'll first think of it as being short. Okay, I'll think of it as being the shortest side, and I'll call it x, 5, and 8. Okay, now the sum of the two shorter sides, x being one of the shorter sides, would be x plus 5 must be bigger than 8. Okay, now I will subtract 5 from both sides of this inequality, and x must be bigger than 3. Okay, so if x was any smaller than 3, it'd be too short to form a triangle. So x must be bigger than 3. Okay, I will next think about that third side as being very long, that it's the longest side. So 5, 8, and I'll call it y this time. So I know that the sum of the smaller two is bigger than the third side. So 5 plus 8 must be bigger than y, or 5 plus 8 is 13, must be bigger than y. Okay, meaning that 13 is the longest that y can be. And if it was any longer, we could no longer make a triangle. So the range of possible lengths for this third side is between 3 and 13 would be the answer.